along like a circle or something. But let's look at a vector expression. How about, this is on page 852. This is in section 13.2. Here's the vector curve they give you. RT, T sine of t, t squared, and t cosine of 2t. What do they want you to do with this? Say, can you find the derivative? Well, I can write that as r prime of t, right? Hey, another name for this vector function, isn't this the tangent function?
Mm-hmm.
So I'm going to write that. Just so I'm in position function, this would be the tangent function with the tangent vector, right? At different variables of t. So we think of this as position. I can also think of this as velocity, true? But they want you to come up with it. I just thought this was a good problem to do because it looks like you got chain rule in there somewhere, and it looks like you also got product rule.
Product rule.
That's why I selected it. What's the only reason?
The first one is product rule, right?
Right. The first one is product rule.
Uh-huh.
First times you're the second plus second times you're the first.
First. So t cosine t
T times cosine of t
plus sine t,
sine t times, what's the derivative of t?
1.
Okay, I'll leave it like that. Product rule, right?
Uh-huh.
That's why I selected this problem, just to update some previous calculus, like, oh, I need product rule because the variable in front of the sine of t. What's that derivative?
2t.
Alright, that's 2t. This one, look, product rule, but you also got a chain
Chain
rule.
rule, yeah.
Let me see the cosine of 2t.
Yeah.
Let's try this. Alright, first,
T.
what's the derivative of the second?
So it should be negative sine
Negative sine of
2t
2t
times 2.
times the chain to 2. Don't agree? Is everyone okay with that? Awesome. I mean, it's just somebody got, oh yeah, chain rule. So the derivative of the second was a negative sine of 2t times a 2. If you get confused between sines and cosines when it comes to derivatives and integrals, then this is just a mnemonic device. SCS, I put negatives on the third and fourth. Going that way is derivatives and going up is integrals. So what's the derivative of a positive c? The integral of a positive c is a positive sign. What's the derivative of a positive c? The derivative of a positive c is a negative sign. So if you like this, great, but it seems like no one has any trouble with that here. Sometimes I'll just see these on exams, just a way to just go, oh yeah, I want to mix this up.
Professor.
So I'm going to finish up product rule. The first times you're the second,
Plus
plus the second, what's the derivative of the t?
1. So yeah.
The tangent vector, that's the velocity vector. That's r prime of t. Cool. So on that note, if this is the tangent vector, yesterday we talked about lines, right? Parametric equations of a line. So, I'm going to give you a vector curve, and I'm going to ask you to find the parametric equations of the line that's tangent to that curve. So let me give you an example. I'll tell you which problem this is. I'd like to do two of these if you don't mind. I'm going to do 23 and 24. Page 852. I'm going to do 23 and 24. The directions say this. Find the parametric equations of the tangent line to the curve at the given point. Alright, here's the first one. R of t.
Professor,
Yes.
can you give the equation for the parametric, for the line? How do you do the line? Do you remember?
Yeah, I'm gonna put it right over here. So for a line, it can be written like this, where you just put the x naught and the y naught and the z naught as a vector, plus the parameter t times some ABC, where this is the parallel vector. Okay? That's one way to look at it. But if they say the parametric equations, I'm going to think of this as what? All this combined, this would be XO, X naught plus an AT, Y naught plus a BT, and Z naught plus a CT. But if they're asking for the parametric equations, let's look at it. X is going to equal this, Y is going to equal this, and Z is going to equal this. The key is, what's this ABC? That ABC is a what? What kind of vector?
Oh,
So now I'm going to draw a picture. Sometimes just a little picture helps. You got a line, you got a point, but we're looking for a vector that runs parallel to it and has, we'll put the components ABC down. We need a vector that's going to be parallel. That's going to be key in this problem. We need the parallel vector at that point off that curve. So hey, another way I can write this, if they say the parametric equations, this was in vector form, right? Then what are the parametric equations of a line? X equals, Y equals, Z equals, X naught, Y naught, Z naught, plus, T, and what's in front of these T's? The A, B, and C. I want to get out of the way. This ABC is the parallel vector. This X naught, Y naught, Z naught is just the point on it that they're talking about. Ooh. But the key is these numbers right here will be the parallel vector. Alright, and number 23. Everyone, here's the vector curve. It's funny because when he wrote this, I'll write it in a vector curve formation. They just wrote the parametric equation. 1 plus 2 squared of t. T cubed minus t. And t cubed plus t. And what's the point? The point is 302. So here's the point they're talking about, 302. We'll do that. Okay. Find the parametric equations of the tangent line of the curve. I'm still lost on what to do. I know these are the parametric equations of lines, so I'm going to draw a picture to help you understand this. This is a vector curve, right? Okay. Woo, there goes the curve, true? Here's some point. The point is what? 302. What are we looking for?
parallel.
Yeah, when lost, we'll draw a picture. I'll draw a line. I need a line that goes like this. Right? I need the parametric equations of a line tangent to the curve at that point. Okay. Here's my answer. What's the point? Plus T. Here's my only challenge. Right here. What are these numbers? What is the vector that I need? What kind of vector do I need? I need a parallel vector to my line. Do you all agree from yesterday? I need a line, I need a vector that runs parallel to my line. A vector that runs parallel to this line would look something like what? Like that? And I heard someone say it. What kind of vector is that? The tangent vector. So when they gave us R of t, all we have to do is, to get these numbers, is first find, I'll draw an arrow, we gotta find R prime of t. That's step one. That's gonna be easy, derivatives. But step 2 is we got to know what t-value to plug in. That's the mystery. They did not tell you the t-value. That's not a t, that's what? X. That's not a t, that's y, that's z. The parameter is t. But let's start with this. When I need r prime of t. This is the tangent vector, right? The parallel vector is the tangent vector. We can see that. And then we'll plug it at some t value. Find the tangent vector at t equal to, I don't know yet. Well, can we just find the tangent vector first?
Mm-hmm.
Let's do the first one.
So
2, 1/2 times 2 is 1. 1/root t. Let's do the second one. 3t squared minus 1. And the last one, 3t squared plus a 1.
well,
And then when I've seen this happen, I didn't want you to make this mistake on tests. This has happened. People write all this, and then they jam it all in front of these t's, and then they like distribute the t. There's one, I know, there's one more step. That's a point. We're going to evaluate these at a t value. The mystery is they didn't tell you the t value. So does anybody have a suggestion when we get lost like this? This is a theme in Calc3. How do I know the daggone missing t value when x is 3 and y is 0 and z is 2? What's the t value there? Do you know?
Just said 3 equal to 1 plus 2.
That's the secret. And so when this happens during our course, she goes, just simply go to the original point, just set it equal to the original x component, and solve for t. If it bugs you, maybe try these two. Pick the easiest of the three to figure out the t value. Right? What does 2 have to equal? T cubed plus t. Oh, that's too hard for me to solve. I'll try this one. 1 plus 2 squared of t has to equal what?
3.
So I'm going to just go off to the side. 1 plus 2 squared of t has to equal 3. By the way, you'll notice it'll be a very simple t value. It'll be a nice neat integer, probably like a 0 or 1 or a 2. I subtract the 1 on both sides. 2 squared of t equals 2. Do you know the t value? The mystery t value, t is equal to what? 1! That's what we're doing. So we're going to put here, everyone, r prime of 1. That's what we're putting in here. We're going to put the vector r prime of 1 right there. Not just r prime of t. We're going to put r prime of 1 as our tangent vector at t equal to 1. Don't let this bug you. It's either t equal to 1 or t equal to 0 or t equal to 2 when you got to do this. And the biggest mistake, people just put this in front of there. No. What's r prime of 1? They're nice numbers. This is what?
1, 2, 4.
See? There you go. Here's the answer. 1, 2, 4. Parametric equations of that line. That's the parametric equation of that line. You described it. And you can find millions of points off that if you wanted to. This is the one I wanted to do 2 of, okay? So, can you try this? You ready? Why? Because this, I don't know, there's something about this that bugs students. Now, here's number 24. They've got x equals e to the t. The y equals, by the way, you both wrote them in parametric form. I'm writing as a vector. T e to the t. And the last one is t e to the t squared. Okay. Wipe this out. Can you come up with the parametric equations of the line?
What is the point?
And the point for this problem, 1, 0, 0. And you find the parametric equation of the line at the point 1, 0, 0. T. And what do I need here? Parallel vector. R prime of what? What's the missing T value here? Anybody know? E to the T must equal 1.
One.
And what T value is E to a T equal to
0.
1? So does everyone agree this is going on at T equal to 0? This funny problem with a funny vector curve, and here's the point 1, 0, 0. We're saying the T value is 0. You all agree? All right, now go find that line L. T equals 0, because E to a 0 gives me a 1. Nice. Go find R prime of 0. All right, what's R prime? Of T. You gotta do that first.
E to the power T.
Remember E to T is E to T. What's your T to T need product rule?
So T E T plus 1.
First time to the second, plus the second time to the first.
So
T times E to the T,
plus E to
plus
the
E to the T times a 1.
1. Yep.
And, okay, be careful on this last one.
You need product and what do you got?
First
Result.
times the derivative, what's the derivative of E to T squared? You need chain rule.
Yeah. 2.
2T E to the T squared. I got enough room. Plus E to the T squared. I'll write this again so it's not all crushed in the corner. And E to the T squared, E to the T squared times a 1. Let me rewrite all this. R prime of T equals E to the T, T e to the T plus E to the T by product rule. Then it was T times 2T E to the T squared plus E to the T squared times a 1. But everyone, would you plug what value of T into all that?